Storage Part 3. In this nugget, we'll be talking about storage. This will be part 3 of a 4-part series. We'll talk here about RAID types. There's a number of different types of RAID you may have heard of. RAID 0, 1, 5, all the different numbers, as well as their colloquial names, which would be more like RAID, whether they're mirroring or striping or something like that. We'll discuss those. Another way we'll attach storage, though, could also be by using SCSI in addition to IDE or serial ATA that we've discussed in the past. SCSI is actually usually more likely seen in servers, so I'm kind of surprised it's on the A+ exam objectives. Nevertheless, we'll go ahead and cover it. And then we'll take a look also at Windows Disk Management. This is a little bit of a lengthy portion in this particular nugget because it does require a lot of attention, and that's where we're going to manage most of our storage, is probably in Windows Disk Management. Then we'll take a look at the drive status that you may also see within Windows Disk Management. A few years back, we built an addition onto the back of our house so that my 92-year-old mother could move in with us so that we could assist her as she ages. Well, as I built this addition onto the back of our house, I also put some nice windows out there so that she could look into the backyard and see some citrus trees that we have back there. Well, she's taken it upon herself to remind me daily that I need to fertilize those citrus trees. You see, she marks it on her calendar that March, which is when I'm recording this, is the month that I'm supposed to fertilize. So every time I've seen her for the past 18 days, she reminds me to fertilize. And I keep telling her, "Mother, you don't need to remind me to fertilize those trees. I'll get it done. You don't need to remind me." So then she says, "All right then, why haven't you done it?" Well, it's because I know that you'll remind me anyway, so eventually it's going to have to get done. Now, if it was a wife, we might say that this was something called nagging. But really, it's something that we call helpful reminders, so that I make sure that I don't neglect my citrus trees out there. Well, your computers also have something that can be used as a reminder, so to speak, or a fail-safe to make sure that they don't lose any of the information that they're supposed to have. That would be something we called RAID, also known as a redundant array of independent, although some people say intensive, but independent disks. Okay. Now, what this is about is it's all about the redundancy. Okay. Now, there are actually some RAID implementations that are not redundant, but we still call them that anyway. And what we have with this, with RAID, is you have multiple disks. That's what redundant is about there. You have more than one disk. Now, what's the purpose of this? Number one, you might just want to increase your storage. You can certainly do that with RAID. And you could take maybe, 4 500 gigabyte hard drives and kind of stack them on top of each other and wind up with a total of 2 terabytes of storage. Okay, so that might be one option that you could use for that. The other thing you might do is to increase the redundancy that you have. So not only do you have increased storage, but you may also want to have some redundancy so that if one of the hard drive fails, and they will fail eventually, one or more of them will fail, then you haven't lost any data. You see, if I just use this first method where I'm using it only to increase storage, if one of the drives fails, then all of the data is lost because the data is kind of scattered across all 4 of them. It's not like it just fills up one and then moves to the second one. With this kind of implementation we're talking about here, what would happen is some data is scattered all over all of them. So I'd lose something if one of these drives failed. With this one, I have one or more drives that kind of have a backup copy of data so that if a drive fails, then we can still retain that data or rebuild the RAID array. And then we also have increased performance. Is another reason for this. You can kind of combine all of these. You could increase your storage and also build in some redundancy there. And some of these will also give you some small performance increase as well. And we're going to take a look at a table that I put together that somewhat describes all of those things. There's many different implementations of RAID, and I'm going to focus on the ones that are more likely to be A+ exam items, especially as listed in the objectives. And then here we'll also have just a note here that in the past, these were really for high-end servers, for production servers where you didn't want to lose corporate data, or your job could be on the line if data were lost, or something like this. Well, we'd have all kinds of method for redundancy there. Nowadays, however, it's also very useful for the high-end workstation, even some gaming workstations and so forth. We'll have RAID involved very often to increase the performance. So let's go ahead and take a look here at a PDF file that I've created about RAID, and I think this is it. Yeah, that should be it. Okay, and we'll take a look at the types that we're likely to see as A+ exam objectives. Also, at the end of our last nugget, we talked about RAID somewhat in terms of configuration of it. Remember, you'll have to access a controller somehow, or the motherboard properties, to be able to configure the RAID array that you need. But anyway, and they're all different, so that's why I don't want to force you to memorize the method for doing that, because they all look a little bit different. But on the basic level, on the lowest level of this, you can have RAID 0. By the way, 0 doesn't mean that it's the least of all of these. It just depends on what your purpose is. This is also known as striping. And with this, you need 2 or more hard drives. This is something that's non-redundant, so if one of the hard drives fails, you lose all of the data. And it does improve the performance by roughly the number of disks involved. And the reason for that is because, let's say that you're writing data to the hard drive. Maybe it's a large graphics file of some kind, maybe it's a couple hundred megabytes. Well, the data is scattered across both of those drives, so it's able to share the bandwidth through to both of those drives. And although you can't really increase the performance by exactly double, because there may also be contention issues with the controller, and there might be other things that are contending for that resource, you can say roughly or somewhat it's increased by the number of disks involved. So if I had 2 disks, that might be somewhat roughly the equivalent to twice as fast, although again, you're probably not going to see exactly twice as fast. This will increase the storage at no disk cost, and that doesn't mean your hard drives are free. What that means is that for some of the other redundancy solutions that we see down here, you actually have to give up a little bit of disk storage space in order to have that redundancy. Well, since there's no redundancy here at all, we don't have any disk cost. In other words, we have not lost any of our available hard drive space. And then we would have something like RAID 1 mirroring. This is a very common kind of redundancy. This requires exactly 2 drives. And what this will do is it will redundantly store the data. So what happens is when the data is written to the hard drive, even whether when you're first installing Windows, even if you already have the mirror set up, then when you install Windows on one of the drives, it's automatically duplicated to the other hard drive. That way, if one of the drives were to fail, you can just pull it out. And very often these are hot swappable, especially if they're using serial ATA. You can just pull one of the drives out. The operating system continues to run exactly the way it did before, with really no performance hit whatsoever. And then depending upon your method for creating this mirror, you can do this within Windows and using Windows utilities to do this, or you could use something like hardware RAID, which is generally considered better because it's dedicated, it has its own processor usually, and it's going to be a better performer as well, so we generally tend to recommend hardware RAID. Anyway, when you insert a new hard drive to replace a failed one, the data on the existing hard drive will be copied to the replacement drive, and that could take some time. That might take hours to do that, depending on how much data there is. So when you're writing the data, there's generally speaking not really a performance increase per se, but sometimes it might improve the read performance because it could potentially read from both drives at the same time. This again depends upon the hardware RAID that you've decided to use. Some of them will be capable of kind of doubling up on the read performance, and some of them will not. It just depends on who your vendor is and so forth. But it could improve upon that read performance. This again can sustain the failure of only one drive. If both drives fail, then of course I've lost everything. But if one drive fails, then I can just replace it and rebuild the mirror. The disk cost is going to be exactly half the total capacity of the smallest drive. Now I don't want to make that too complicated. Let's start with 2 drives of the same size though. If I have 2 1 terabyte hard drives, then the exact same data is being written to one drive as is being written to the other. Okay, and so since they're really just duplicates of one another, I don't have 2 terabytes of total available storage. I really only have 1 terabyte of total available storage. But if I have one drive that's 500 gigabytes and the other drive is 1 terabyte, with a mirror, it can only be as large as the smallest hard drive. So in this case, my mirror would be 500 gigabytes. Okay, so that's just an example of how all that works. So to summarize all of this with a little drawing here, if I have RAID 0 and I have some files being written, then it's going to be scattered between these. So I might have, if I use this word as kind of the illustration of that, I might have F here and an I here and an L here and a E over here and then an S. So you can see the files are scattered back and forth between these 2 drives so that if one of them fails, I don't have any meaningful data left on the other one. Also, if both of these drives are 500 gigabytes, then I have a total of 1 terabyte of storage because I'm able to use all of the storage on both of these. With RAID 1, however, if I have files being written, then it's written exactly the same on both of these drives, and I have a full copy of whatever my data is on each one of these. So if this one fails, then I still have all of the data, and there will really be no disruption in service. I would then simply replace this drive, and then the data would get copied over here so that, over some time, could take hours, I would have, again, an exact duplicate of data here, and we would have no failures going on. Then also with the storage, what if this one's 500 gigabytes, this one's a terabyte? Well, you can only use the same size as the smallest drive for your total storage, so I have a 500 gigabyte RAID 1 array. Then going back to our RAID types here, we also see RAID 5, which is also known as striping with parity. With this, you need at least 3 drives, but you can use more. The more drives you use, the potentially better performance you'll have, at least on the read performance. This is a redundant method as well, so that one of the drives could fail, and I would still then have all of my data. This does somewhat improve the read performance because although there is a parity calculation that takes place with the RAID 5 array, there are no calculations that occur on the read. On the write, there has to be a calculation made, which could potentially slow down a little bit, although today's processors are very, very capable, and so I don't think you're going to peg the processor. Although, once again, it's better if you use some kind of a dedicated RAID card or some kind of dedicated a motherboard that has dedicated RAID on it so that it does not use your main CPU. Instead, it uses an off-CPU processor to perform these calculations for you. The write performance can increase, like I said, because of the parity calculation, although much of the time nowadays that's not as big of an issue as it used to be. Again, most of the calculations are going to be performed on hardware instead of your main CPU. Also, as I said, it can sustain a failure of one drive, and the disk cost is the total capacity divided by the number of drives. And so then to illustrate this here with RAID 5, what would be going on with this is, again, maybe I have my files, now I have my 3 drives, and you can have 3, 4, 5, 10, however many drives you have room for or connections for. And as I write data on this, we might have an F going over here, and then an I here, and then instead of an L over here, it's going to have parity data, which is data about the F and the I. So if the drive with the I ever fails, then the parity data is a calculation that occurs so that it can kind of reverse engineer and figure out what this used to be. So that when I replace this hard drive, it will then say, because of my parity data, I know that that was supposed to be an I, so the controller, the RAID 5 controller, will write an I to this new replacement drive, and that's kind of how that works. So it might be FI parity data. This is also scattered, shared around each one of these, so in kind of in a round-robin fashion. Then when we write the E down, okay, or rather the L down, excuse me, then the L might be written here, and the E would be written here, but now the L and the E are here, but then we would have parity data here. The parity data here would be able to reconstruct either the E or the L if one of these outside drives here failed. Okay, and then we would have, of course, an S, and then other parity data again get scattered around to this drive eventually as well. So this would allow us to be able to sustain the failure of one of these drives and have parity data recalculated and rebuilt for us. This can be very intensive on the rebuild because now, instead of just doing parity calculation a little bit, it has to reconstruct entire hard drives, and you will see probably a significant performance decrease during the time that this takes place. Plus, it's very disk-intensive to rewrite all that data. Now, for the size of this, if I've got 500 gigs here, 500 gigabytes here, since I'm losing a third of the storage to the parity write on each one of these drives, then I don't have a total of 1.5 terabytes. My disk cost is the total storage, which would be 1.5 terabytes, divided by 3. So that would be 1.5 divided by 3, which would be 500 gigabytes would be my disk cost. Therefore, my total storage is 1 terabyte in this situation. Then returning back here to take a look at RAID 10, there's no such thing actually as RAID 10. We just refer to this usually as RAID 10 because it's easier than saying 0 plus 1, or you could also say RAID 1 plus 0. There's actually a subtle difference between the two of them, but overall the net effect is usually the same. But there's 4 or more drives, and you have to use an even number with this, although most of the time people stick with just the 4 drives. This is a redundant method. It will improve somewhat your read performance, again, depending upon your controller and overall bandwidth performance. It can sustain the failure of one or more drives. You could actually have, in some cases, possibly 3 drives fail and still have everything. We'll show you that here in a moment. And then the disk cost is half the capacity of the total storage size. So let's go ahead and take a look at RAID 10 here. What happens here is you start with RAID 1, or mirroring. Remember, with our files, we'd have files here, files, and we would have files here. Okay, this is mirrored data back and forth between these 2 drives. Okay, so as the data comes out of my system here, it gets mirrored to both of these drives. But then the next thing that happens here, or actually this all happens simultaneously, is that in addition to that, it then will stripe to these. So we would have a RAID 0 going on over here. Oops, lost my pen. There we go. RAID 0 going on over here. So we'd have FILES. Okay, so with this kind of a situation going on, I could lose this drive, or this drive, or this drive, or all 3 of these drives, and still have 1 copy of all of my data. So in that case, I could lose 3 drives. In some cases, however, you cannot lose all 3 drives. If I were to lose this drive, and this drive, and this drive, for example, there's not enough data left here to rebuild anything, and it would be a total loss. All right, now let's here move on to the subject of SCSI. Now, what is SCSI? Well, it's more than just the nickname that the girls in college used to give me. SCSI actually refers to something called the Small Computer Systems Interface. And the reason why we say small computer as opposed to some other kind of computer is because this standard is decades old. It's been around for a long time. And it used to be that in server rooms, you really didn't have PC-sized computers. They were all like mainframes, gigantic things, you know. They could be 6 feet tall and 1,000 pounds. So these could be really, really big systems. And so comparatively speaking, even though your own desktop computer is more powerful than any of those mainframes of old from decades past, they're still called small. Anyway, it's the acronym stuck. This is still, however, mostly reserved for servers, because SCSI is something that you don't normally see in desktop computers for the consumer level, or even for high-end workstations. We are generally using other technologies instead. And for that reason, SCSI, I think, is going to have less emphasis on the A+ exam objectives than it has had in the past. Although it's still kind of novel and useful information to have, I think you're going to see it have more importance for server plus topics. But one of the reasons why it is important for servers especially is the high performance that it does yield. It can go up to 320 megabytes per second, which is pretty fast. Also, it's not just for hard drives, although we mostly use it for hard drives. We just finished our discussion on RAID. Very often for servers, the RAID arrays that are used there will not be using, IDE or something like that. That's child's play. No, for a server, you would use something like a SCSI RAID array instead. And very often you would connect an external drive cabinet with maybe a RAID 5 array of, 10 drives in there through an external SCSI connection to that cabinet. That's very often how that might work. It's also very good for other devices. It might be a scanner, a high-end laser printer. It might be, external storage of some other type. It could be optical drives. Oh, here's a good one, optical. It could be tape. Very often, tape is used on a SCSI connection because of its high throughput, and you want to use as high a throughput as you can possibly get to tape, because tape is slow enough on its own as it is in most cases. Also, with SCSI, you do have to have a certain termination that's involved in this. This will help to So let's also illustrate this a little bit. If I have a SCSI adapter right here, this could be used for a couple of purposes. I might have an internal connector here, which connects a wide ribbon cable to, storage. Okay, and this might be connecting to one hard drive here, and then it might be daisy-chained so that it connects to another hard drive, and then daisy-chained so that it's connected to another hard drive. Maybe this might be, a RAID 5 array, or you might have only 2 drives and have it be a RAID 1 mirror or something like that. So I can use it internally. A lot of these devices will also have external connections here, so that I might have a ribbon cable going out here, and I'll just use a single line because so that it's easier to draw. And this first one might go to some kind of a optical drive. Okay, and then I might have something else connected here to a scanner. Okay, just a flatbed scanner. Okay, and then I might have another one here that connects to, a tape drive of some kind. I'm just kind of thinking of other things we could use here. Now, what I would have to have here with termination is you terminate the last device on the chain always. So here, the last hard drive, this would be terminated. This would be terminated on. This would be terminated off. You have to always make sure you only do the last one. Terminated off. These can be terminated a number of different ways. There might be some kind of a switch, or a dip switch, or a jumper, or something like that. to turn these off or on. Okay. Again, always the last device will have that. And then for these, again, these will also be terminated off. And then same here, terminated off. And then this one would be terminated on, which looks like ton, but it's supposed to be terminated on. And we have to signal that because if we don't terminate this as terminate this here, then you have problems with the signaling going back and forth along this, what we call a daisy chain. And then as it relates to the SCSI specifications, I'll have this as well as that RAID document I showed you earlier available up again on nuggetlab.com. But what we have with this is a number of different specifications, and this goes pretty old, back to SCSI 1. This goes back a few decades. And this will identify the bus width, the available throughput in megabytes per second, how many pins are in the cable, the signaling, which in this case, SE would mean single-ended. This example here would be high voltage differential. And then later on down here, you'll see low voltage differential. Most of these up through here on the top part of this are pretty well old. I don't think you'll really see much of these, if anywhere, anymore, but I just kind of include them here as information only. You're more likely to see things further on down towards the end of this, probably starting with SCSI 3, or Ultra SCSI as it's also called, on down through to the end. And they all, again, have different names, kind of similar to what we saw with Parallel ATA or IDE earlier on in our previous nugget, where we were talking about ATAPI, which is also known as, Ultra DMA, or, all that kind of thing. So what we have with this as well is that we have different lengths that you can also use. Okay, if we see that, look at the top of this, we'll see the maximum number of devices, including the host adapter, and that's why these say 8 and 16 instead of 7 and 15, because the host adapter is included in the number of devices. But in terms of the additional devices you can have 7 or 15. Then the maximum cable length, different things will have different cable lengths. One of the advantages of high voltage differential, you can see here, pretty long cable length at 25 meters, but that's really been mitigated now because you don't really need that anymore. High voltage differential sometimes can actually damage devices, especially if you get some of these mixed up. You can mix and match some of these, but you have to check with the vendor, and you have to be very careful about which ones you mix and match and which ones are capable of being on a certain bus. For example, a single-ended could generally be lower performing, like an Ultra 3 single-ended, could go on one of these low-voltage differential connections, for example. However, the whole bus would then operate only at the slower 20 megabytes per second, as opposed to 80 or one of these other speeds that we see down here. So you still have to be careful about mixing and matching these things, and it's safer and easier if you just try to stay on a single standard, but that's not always possible. And then what we'll have here also is some additional notes that you'll see down towards the bottom. I was talking to you about common SCSI ID assignments. Generally speaking, for example, you don't have to do this, but you should. ID 0 is usually the bootable hard disk. ID 7 is usually the host adapter itself. ID 3 is the CD or DVD if you're using those on a SCSI chain. But once again, a lot of these are kind of becoming defunct because look at the fastest speed, for example, of SCSI 3. Although it's 320 megabytes per second, we get that same speed just about with serial ATA 2. Now, a lot of server shops are still going to use SCSI because that's the existing hardware infrastructure that they have. The administrators are familiar with it, and they know what its capabilities are. And as a rule, it's still going to give you probably the highest, most reliable, constant throughput when you use SCSI. You might get, on paper at least, pretty close to the same performance with serial ATA, but in practical implementations, you might actually see a better performance increase with this SCSI instead. However, for most users and even power users, serial ATA and a lot of the serial ATA RAID solutions that are integrated into motherboards or in adapter cards are very often more than adequate, and we don't need to go to this because this is also quite expensive when you consider that you might only get a nominal improvement in performance at a substantial investment and complication of the installation. And then for your visual reference, I've got a 50-pin SCSI cable here, which is useful for a number of the different SCSI standards, such as SCSI 1, SCSI 2, SCSI 3. Then there's also the Ultra SCSI. It would work for a number of those different kinds of connections. If you take a look at it, you'll notice that it is slightly wider than the 40-pin IDE connector, but not quite as wide as a 68-pin. Now, here I've logged on to Windows Vista, and I want to show you how you can manage these disks, and this will be regardless of whether or not you're using SCSI or IDE or Serial ATA or any of the other kinds of standards. This is kind of agnostic to all of that. But what we want to do here is to right-click on the computer and choose Manage, and as an administrator, you should see a prompt here that allows you to continue. And the reason why this pops up is because you don't want a casual or uneducated user accessing a lot of these settings, because these could damage the system. You wouldn't want to, I don't know, a 5-year-old to be able to make some of these changes, although in many households the 5-year-olds know more than the adults do. But anyway, here I want to show you the Computer Management Console. Now, Microsoft uses something called the Microsoft Management Console, or MMC, to give you these management tools. Here over on the left-hand side will be the main category of what you want to do. We would click on Disk Management here shortly. And then in the middle, it'll show you specifics about the item that you've clicked on. And then on the right, you can choose various actions that you want to perform, which I'm going to remove by clicking this button, because all of those actions we're able to perform using other methods, such as the menu or by using right clicks. Now, when I click Disk Management, it should show, and there it is, 4 additional disks that I have installed into this computer that have never been seen by Windows before. And as a result, they have to be initialized. When they get initialized, the Logical Disk Manager will assign a serial number to each one of these disks. And then from that point forward, if we decide to also do something like convert them to dynamic disks, and I'll discuss that again later, then we could create something like a RAID array using Windows methods instead of using a hardware adapter, for example. But otherwise, I'm just going to go ahead and allow these disks to be brought in. I'm going to use the master boot record type, although I could also have chosen a GUID partition table. GPT is generally recommended for disks larger than 2 terabytes or disks used on Itanium-based computers. For the consumer-level PC side of things, I don't think you'll ever see an Itanium-based computer. It's a special high-powered processor that's generally used for server machines. Okay, so anyway, we'll go ahead and just click OK here to initialize all of those disks, and we'll wait for them to be recognized. And then once those drives appear, let me resize this a little bit so I can get a little better view. Then we'll see these additional 4 drives down here. Now, so far, they're not really useful for anything. And what I want to point out here is we're going to see some different terms that are included in here that I'll also want to identify here as well. Okay, so one of the first terms that we'll want to identify, I'll just do this in no particular order, is basic. This is as opposed to dynamic. That's not actually even on the whiteboard that I showed you there, but I'm not sure that it's an A+ exam issue either. But basic means just a general disk. It's just basic. That compares to a dynamic disk, which is only readable by a current Windows operating system. Once it's been converted to dynamic, which I can do by right-clicking and choosing Convert to Dynamic Disk, then I can make it a RAID disk. I could create a mirror or a stripe, striped with parity, in other words, RAID 5. I could do all those things, and it would create that RAID array using Windows methods instead of hardware methods. Again, hardware methods are definitely preferable. This is also online, which means that it's available to start working with. I could also right-click on this and choose to, actually right-click here, and choose to create a new simple volume. Okay, notice that it's unallocated right now. It needs to have a volume created, and also it needs to have formatting created on this. I can use this interface that we see here, or I could also use the format command, for example, once I've created a partition. Or I could also use the diskpart command, which is a command line utility within current versions of Windows, but it's much more cumbersome than just, right-clicking on stuff. So just by way of example, let me just go ahead and create something simple. I'll create a new simple volume. Okay, and by clicking on this, it'll start a wizard, which I next my way through. I specify how big I want the volume to be. I don't have to use all of the space. I created these as kind of small hard drives so that they'd be easy to manage. I'll just use all the space in this case. And then I assign a drive letter to this. Now, from this point, we have a number of other options that we could choose as well. I could leave it at drive letter F or any other drive letter I select, or I could mount it in an empty NTFS folder. What that means there is that I could go to my computer, for example, and maybe I only want a single drive letter. I don't want to see an F and a Q and any other drive letters in here. Well, instead what I could do is create a new folder here that's just empty and doesn't have any files in it. And then what I could do is I could link this new storage on this drive that I'm working with to that empty folder. So in order to access that storage, all I would have to do is to click on the folder in drive C, and it would look like the storage I'm accessing is on drive C. In reality, it links it to this storage that I'm about to create. Okay, so I could click on Browse, and I could create a new folder on drive C, whatever name I wanted it to be. In my case, I'm going to keep it simple and assign it to drive letter F, or I could not assign any drive letter to it at all if I wanted to as well. And then I would choose to format the volume or not. Now, I don't have to format this volume in order to create a partition. The wizard makes it convenient because eventually you're going to have to if you want to use the storage. So I'll just go ahead and format this, and I'll just call this, data 1, for some reason or the other. Then I'll choose what file system I want. There's FAT. There's FAT32, and there's NTFS. Now, I've got a document here, and I'm just going to drag this over briefly here, which outlines all of the various file systems and which operating systems they're compatible with and the like. I'm not going to elaborate on this very much right now, mainly because we almost always want to stick with NTFS. This is the highest level that you can choose in most cases, unless you're using something like a USB flash drive or something like that, in which case there's a new file system called exFAT, and you can see a note down here about that, which might use for USB flash drives. Otherwise, NTFS is generally the way to go, although you do need to know about these other file systems, and this is a document that's available for you named filesystems.pdf, and it's available for you up on nuggetlab.com. By the way, when I talk about these files on nuggetlab.com, you don't download them individually. They should all be in a zip file, so you can download the whole thing all at once with all the files that I'll talk about through this series. And then what I'll do is, I want to create a quick format. Now, I don't have to do a quick format. I could just leave that empty checkbox, and it would still format the drive just fine. It would just take substantially longer. And what it does certain disk checks as it goes here. Most of the time, it's not a problem to use a quick format. I could also choose to use file and folder compression, which is still available, but not as popular because hard drives are so much larger these days. Back in the old days, when hard drives were much smaller and free space was at a premium, you might have used compression, which might give you roughly a 2-to-1 compression, so that a 100 gigabyte hard drive would be roughly 200 gigabytes, but we don't use that as much as we used to in the old days. It also does have a performance penalty because to perform that compression, you have to use the CPU to be able to squish that data down. So now I've got a partition here. We can see that it is online, it is basic, it is a healthy primary partition, and I'm just going to address some of the things we've already discussed here. We have a healthy partition, and we have it online. We also saw that we have some offline drives there as well. And if we had, really quick vision, we could have seen that during the format process, it would have shown it as formatting as well. Now, once this is done, I can just start using this. I can even right-click in here and choose Explore or Open, and I can right-click and choose a new file or whatever I want it to be. James Christmas list. Okay, I'm thinking a little bit early. It's only March, but you people all still have time to shop, so I'm going to start compiling things. How about a new Nikon? I mentioned this earlier, D3S. Okay, it's only about $5 or $6 grand. Okay, so start saving your money. Okay, so I can save that file. I now have a document there that I could start to work with. All right, so it's pretty simple in that respect. If for some reason I decided to get rid of that, then a number of things I could choose to do. Number one, I could choose to format this drive, which would just erase all the data and make all the drive space available again. I could also do a number of other things here. I could choose to mark the partition as active. I don't really need to do that in this case, and the reason why is you only mark the drives that are active that you want to be able to boot from. Notice that drive C up here, if I scroll up, drive C, which is where my operating system is located, is the system drive. It's the boot drive. It's got a paging file on it. These, I can explain all of these when we talk more about Windows later on. But in short, system is the operating system files. Boot is key files that are necessary to start up the operating system. Page file is going to be used in place of random access memory if I start to run short on random access memory. It's active, meaning, which is very closely related to boot. It cannot boot unless it's also active. And then it's a crash dump and a primary partition. Crash dump will just take data in event of a severe crash, and it will dump that out to the hard drive that can be used for analysis later on. It's also a primary partition. Also, you boot from primary partitions. Although you can have multiple primary partitions, you'll probably only have one that's a primary and active. You can only have one active partition in the system at one time. Okay. So anyway, that's kind of the rundown on what those things there are. And then other things I could do with this, I could take this and I could shrink or extend the volume or delete the volume. Now, shrinking the volume is something that's new with Vista and Server 2008. With this, I used to have done this using third-party products or using the DiskPart utility, which is a little bit clunky because it's all command line. But if I shrink something here, then I can say I want to shrink it by, let's say, 100 megabytes. Now, why would I want to do that? Well, maybe I'd want to do that if I had an additional partition that I wanted to dedicate to a certain kind of data or storage or something like that. And I just, arbitrarily just selected 100 megabytes, which, because of rounding, you see that it goes to 102 megabytes. So now I could then right-click here, choose another simple volume, and create another drive letter there if I wanted to. Later on, if I change my mind, then I can say, hey, this needs more space. Maybe I'm running low on space. I can extend into this unused space. So I can right-click here, and then I can extend the volume. And then as I click on Next, notice that there's also these other disks, which so far don't have any use. I don't have any partitions on them or anything like that. Right now, I've got the one selected. I could add an additional one in here like this one. However, since these disks are not yet formatted or anything like that, and in order to extend across to a different disk, I would have to make it dynamic. That's another reason for using dynamic disks in Windows for things like RAID and this. In this case, I'm just going to stick with the one I had. I'm going to remove that one. I'm just going to stick with the one I had and increase it by 101 megabytes or 100 megabytes, I'll put. And then we'll see that when I click on Next and Finish, it has now reoccupied the space that it had formerly given up. Now then, quickly, I went ahead and opened up a command prompt. Notice this is an administrator's command prompt, which I get to by right-clicking here on command prompt and choosing Run as Administrator. And then once I've done that, I can use the DiskPart utility. I don't think you need to memorize these commands. I'm just showing you that this is another alternative. A lot of administrators will like to do this because they can batch file it or script it, or they just prefer the command line. Anyway, running DiskPart takes me to a DiskPart command prompt. Notice it's not C:\\Windows and all that. It's just DiskPart. Then I need to identify which disk I want to use, so I choose List of Disks so I can get the list of disks that I have. Disk 0 is where my operating system is. Disk 1 is the one I've been working with here in computer management, in disk management. And then what I would do is I'd choose Select Disk 1. Once that's been selected, then I would choose to list volumes. I need to know what volumes are available. What I want to do is to work with volume F. So I'd select volume 1. And if I wanted to shrink it, what I would type is shrink desired equals and then however many megabytes. Because of virtual disk issues, since it's not a physical operating system, it's actually a virtual machine, it gives me an issue with virtual disk, so it cannot support that on this particular interface. But otherwise, if it was a normal physical machine, I would be able to shrink that drive. Now let's go ahead and delete this volume here. And then I'm going to go ahead and work with creating a different kind of a volume, a striped volume. Now, since this is not a server, then it does not give me the option to create a RAID 5 with redundancy or a RAID 1 with redundancy kind of a volume. So I'll choose a striped volume. That's the only thing that's available in this operating system. And I'll just select all these other disks and choose to add all of them. And then what I want to do with this is I want to specify the maximum available space in megabytes. Notice that I can go up to 4084, so 4084 is the maximum I could go. Sometimes it still won't let you go, though, because of rounding and stuff, so I'm going to make this 4080 and see what that does. Oh, that's not right. I'm sorry. I'm blowing that. What you got to do is you enter in the maximum available space on the disks. So it's 1021, and then when I click on Next through this, then it will use 1021 megabytes on each disk. That's why it's going to give me a total of 4084, which would be, what's that, 4 gigabytes, okay? So then I click on Next, and again, I can assign it a drive letter. I'll just call this one striped, okay? And then I'll perform a quick format, and then we'll see that when this is finished, it also has to convert it to a dynamic disk, as I've mentioned earlier. So as I click on Yes, give this a few moments, we'll then see that we have a striped volume across all of these physical disks. Then when this is done, since these are now dynamic volumes, and you can see dynamic on the label right there, then we're able to save data to these. Once again, I could explore this, and I could just create files and folders and save data to that, but I'm sure you understand that much. So anyway, there we go. And if I wanted to tear this down, once again, I could then delete the volume and say yes, and that would be pretty much all there is to that. Once a disk is or the volume is deleted and it depended upon being a dynamic disk, now that it's all gone, notice that it reverts back to a basic disk. And then returning to our whiteboard, there's a couple things we didn't address. Actually, we did, but I'll just put them out here as well. Remember, there are active volumes. There's also unallocated space. The exam objectives put active and unallocated on the same line. That is not really necessary. These are two separate things. But I put them on the same line here just because that's the way they are on the exam objectives. I don't know why they did that. Anyway, also, there's this failed redundancy item. If you are using it like a RAID RAID 1, RAID 1 or a RAID 5. Remember, those have redundancy, and we're not going to see that on the version of Vista that I was using just a moment ago, but if you have a version of Windows that supports RAID 1 and 5, then you'll see that if one of the drives fails, that volume will then say failed redundancy on it. What you can do at that point is to replace the drive, and then once you've done that, you can it can rebuild automatically. Or you could also see that if you have transported some dynamic disks from one Windows machine into another one, it'll recognize that they're dynamic disks and that they were built on a different machine. So it'll see that they are foreign, and you can right-click on it and choose that you want to import them into the current machine if you like. Now, there are a few other things that I can do from within Windows to manage these disks. One of those things might be to use the format command. Now, we saw that how you can use that in the interface a little while ago from within this. It can be part of creating a simple volume, for example. So I could create a simple volume here, and next I'm just going to make this real short and sweet. So we'll just send out a drive letter again, and you've already seen me go through this, so I'm going to be very, very quick with this. And then as I click on Finish, we got our 100 megabyte drive. We see that it's formatting and that it is now healthy. What I wanted to do, though, is I might want to format that drive just to erase the data on it. Maybe it had something on there that was personal or something like that. So I would format it so that by a casual glance at least, nobody would be able to see that there was ever any data on it. One thing to keep in mind with this is that formatting it does not truly erase the data. There are utilities and methods that can be used to recover data on a partition even if it has been formatted. Okay, it just erases it from a casual view, but educated users might be able to still retrieve data from it. There's also the format command from a command line. I could format drive F and with a /Q, and then I would have to enter in the current volume label for drive F. This is kind of to prove that I know which volume it is, and that would be new volume is what it's called. Are you sure you want to do this? It's going to remove all the data. Yes. And then I can enter in a new data here, or rather a new label here as well. I'll call it data 3 or something like this. Okay, and then there we go. Now we see that from a command line we have formatted this as well. You probably should know how to do this from a command line as well, because format's kind of a common command. And then some of the other things we look at here, I've already talked to you about disk part. There's also various types of partitions. In Windows Vista, when I create a partition, it's always going to be a primary partition. And we already talked also about active partitions. But in Windows XP, for example, I could create an extended partition. And then within that extended partition, you can create logical drives. And the reason why you would want to do that is because with primary partitions, there can only be a total of 4. However, if I've already used all 4 and I need more, for example, then I could create one extended partition. If I do that, then I have to, instead of creating 4, I have to create 3 primaries. If I'll max out my primaries, and then one extended. And then within that extended, I can create several different logical drives. So let's go ahead and take a look at how that might look. Here we've got a Windows XP machine. On this Windows XP computer, I'm also using computer management here, as you can see. And what I want to do with this one is, look, I've got some unallocated space here as well. I'll just right-click here and choose a new partition, then click Next. Notice that here I could choose an extended partition, and I can specify the size of it. I'll just leave it all, and then Finish. And then once I've done that, now I can choose to right-click here and choose a new logical drive. And then when I choose a new logical drive within this, I specify how big I want it to be, 100 megabytes or something. Again, a drive letter, and everything else is pretty much the same as what we saw in Windows Vista. And I'll just call this data 4 or something like that. And then Finish. And then we'll see that we now have in this extended partition here a logical drive. And then I could go right-click here and choose additional logical drives if I like. And this helps me to get past the fact that I might otherwise have only 4 primary partitions. And if that's the case, then I have to make sure that I limit myself to only 3 primaries, create 1 extended, because you can only have 4 total. And then within this extended, I create my logical drives. And then I already also talked to you about mounted drives so that you can mount this to an empty folder, for example. And then finally, there's a utility here called Disk Defragmenter. This is also something that's available on both Windows Vista and Windows actually all current versions of Windows, starting from Windows 2000, in fact. But I can right-click on this, and on any of these drives. I can do this from Windows Explorer or from this interface, whichever one I want. And then if I go to Tools and Defragmentation, I can choose Defragment Now. And what it can do is it can analyze it to see if it needs defragmentation, or I can just choose to defragment now. Now, this schedule that you see here is there by default. I never, configured that. It's just kind of already automatically configured to do that. But I could also choose to manually defragment now, and I could then choose, which disk it is that I wanted to defragment, and click OK. And then it would just start doing its defragmentation. Now, that's all well and good, but you might be wondering, okay, James, what's fragmentation? Well, what you see happens here is I have a hard drive. And let's say I have a file, and I'll just say that this represents a single file. And then once I save that to the hard drive, it represents, contiguous space potentially, where the read-write head only has to read continuously across this file. But then I start to add in other data, other files in here. Some other stuff takes space. So now next time I want to open this file and add a whole bunch more pages to it or something like this, then it can't grow directly adjacent to its original location because there's already something else there. So then what it has to do, and let me change color to make this a little bit more clear. See if I can go to blue here, for example. Then what it has to do is it has to take this original file that we had right here, and it has to tack on at the end over here. Okay? So now, when we have to read or write to the file, it has to read both from here, and the head has to dance back and forth on the hard drive between these. Defragmentation will take this space out here where it kind of got orphaned and stuck out here in the middle of nowhere on its own, and it will then paste it onto some other location that's available free space. And so it might paste it onto here, or if this file is in the way, it could actually move that file over a ways, and then it could paste on that that data here that kind of got left dangling. So it kind of moves it all, so it's now, again, contiguous data, and it's much faster for the hard drive. Now, this defragmentation software that's included in current versions of Windows is actually a kind of a miniature version of a product licensed from Executive Software, which makes Disk Keeper. Definitely, if you want real disk defragmentation to take place to get the optimum performance, you really should use the Disk Keeper product. Because it can truly make a pretty dramatic difference in your overall performance. Well, I guess I better get out there and fertilize my citrus trees before my mother gets on my case about it again. So let's just go ahead and conclude here with our discussion of storage of Part 3. Here we talked about RAID types. Remember, there's RAID 0, 1, and 5. Those are the key types that we'll be just concerned about on the A+ exam, although there's also RAID 10, as we call it. There's also the ways of connecting hard drives. We've already looked at IDE as well as serial ATA, but there's also SCSI methods, and this is something you can use to connect not only hard drives, but other types of devices as well. This is something you're more likely to see on higher-end workstations and even more likely on servers because they're highly reliable and they perform very well. We looked also here at Windows Disk Management. This is where you're going to be performing most of your disk administration, everything from creating partitions to deleting partitions, bringing disks online, creating arrays, all that sort of thing will be normally done there. And then we took a look at the drive status as well, and this is where you can identify whether it's online, offline, whether it's failed redundancy, and a number of other things. Well, I hope this has been informative for you, and I'd like to thank you for viewing.